In this segment, we'll talk about the LU decomposition method. We'll do that through an example. So here is an example. We're asked to simply solve this set of equations right here. We are given the LU decomposition of the coefficient matrix. This is our lower triangular matrix. This is the upper triangular matrix. So it's already given to you. If you want to figure out how we do the LU decomposition of the matrix itself, go to the video description and you will see a link there. What which we need to do is let's first recall what LU decomposition is. We have AX equal to C. We write our A in the LU form, and then we say, hey, we got to first solve L times Z is equal to C, and then we got to solve U times X is equal to Z. So this becomes our first set of equations. This becomes our second set of equations. And once we find Z here, we put it back in here, and then we can find X. So let's go and take this first part separately and this second part separately. So the L times Z equal to C would look like this. So that's our L matrix. And then we are saying, hey, this is our Z vector, and this is our right hand side vector. And as you can see, what we'll do is we'll solve it by using forward substitution. So this is L times Z equal to C, and the part of the LU decomposition method we are doing here is forward substitution. So if you look at the first equation, we'll have Z1 equal to 106.8. Then the second equation will look like this, and we expand the third equation, we will get this equation right here. So it makes it clear that hey, we need to solve this equation first. That's for Z1. Then we can solve for Z2 here, then solve for Z3 here. So Z1 is already 106.8, so we don't need to go any further than that. We take this one, we say Z2 is 177.2 minus 2.56 Z1 divided by 1. So we don't need to really divide by 1, but let's just show it there. So we got 177.2 minus 2.56 times Z1, and this number here turns out to be equal to minus 96.208. Let's go and do this third equation here. So that's what we'll get for Z3 will be this quantity. So we substitute the values of Z2 now, which we just found out, and we substitute the value of Z1, which we found out from the first equation, and this number here turns out to be equal to 0.76. So what we have found out is Z1 here, we found Z2 right here, and we found Z3 here, and this is what we're going to be using in the back substitution part. So we have found out what the Z vector is at the end of the forward substitution steps, and we find Z1, Z2, and Z3 to be equal to 106.8 minus 96.208 and 0.76. So what we have to do now is we have to do the back substitution part. So that's back substitution. We already know what U is. We just found out what Z is, so we can find out what X is. So if we write down our equations for Ux equal to Z, This is what's it going to look like. So let's write down what the U matrix is, the upper triangular one. Multiplied by our unknown vector x1, x2, and x3. And here I'll have 106.8 minus 96.208 and 0.76. So what we're going to do is in the back substitution, we start with the last equation first. So that gives us 0.7x3 is equal to 0.76, because it'll be 0 times x1 plus 0 times x2 plus 0.7x3, which is right here, equal to this quantity. And that gives us x3 is equal to 0.76 divided by 0.7, and we get 1.0857. Let's look at the second last equation. And we'll get minus 4.8 x2 and minus 1.56 times x3 equal to minus 96.208. There's no x1 term because we have a 0 here. And what does that give us? So if we write down what x2 is, and we write it in the same form as we would be doing it if we were doing this through a computer program. So that's why I'm taking things to the right side and dividing by the coefficient of x2. So we get this quantity right here. And this number here turns out to be equal to 19.691. So let's go and see what do we get from the first equation, which is right here, which will have all the unknowns. But at the same time, we already know that we have found the other unknowns except for x1. So I'll write down x1, or write down the equation in terms of x1, because that's the only unknown. And now we substitute the values of x2, which we just found out, and x3, and this number here turns out to be equal to 0.29048. So we have basically found out what the solution is. The x vector is x1, x2, and x3, and that turns out to be equal to the following numbers. So we have found out x, and that's what how LU decomposition method works. And that is the end of this segment.